Hello and welcome to my YouTube channel on sustainability. The aim of today is to encourage knowledge in the marketplace with a view to helping people to uptake renewable energy technologies. So please subscribe to my channel if you like what I'm saying. It's absolutely free to do so and you can unsubscribe at any time. So today specifically I want to look at air source heat pumps, their role in achieving carbon net zero and the parameters you need to think about when choosing one. This video is aimed really at homeowners or architects. So home heating with gas or oil is responsible for around 20% of CO2 emissions in the UK and the US. And ahead of COP26, which is taking place in Glasgow later this year, the International Energy Agency has called for a ban on fossil fuel boilers unless they can be used in conjunction with hydrogen. So air source heat pumps are a huge step forward. They are the replacement to gas and oil boilers. However, unlike gas or oil boilers, there are many factors that need to be taken into consideration when choosing the correct system or, really crucially, the correct size of system. So, an air source heat pump works best in a really well insulated property. You need to look at glazing and insulation. Insulation in your loft you can fix really in a weekend with a trip to B&Q. Windows need to be properly glazed, obviously at least double glazed, and sealed with a view to preventing heat escaping through cracks or gaps. The key is heating the airspace. And not losing that heat. So, how does an air source heat pump work? Generally speaking, what we'll talk about here is residential properties, and we'll talk about the heat pump, which in those situations is usually air to water. Air to air is a little bit noisier, so tends to be used on a commercial basis. So an air source heat pump is like a reverse fridge. It takes low-grade heat from outside, and it is then compressed using high pressure refrigerant, and the heat brought inside is then used to warm hot water. The UK market tends to be split between either a split system or a monoblock system. Split system, the piping is not coupled up, so when it arrives on site, an F-gas supplier needs to couple up the refrigerant piping. A monoblock comes already coupled up. And air source heat pumps work best where there is underfloor heating rather than with a traditional radiator. So a traditional radiator runs at around 60 degrees Celsius. Your air source heat pump will heat your water to about 45 degrees. So you've got your property insulated, and the key then is to get the correct size system with the correct size radiators or underfloor heating. We'll come on to that in a little bit. Also, there's an important factor in seasonal coefficient. So when calculating the size of your system and the use of a particular air source heat pump, you have to look at the microclimate in your area. So actual address data needs to be used to look at the seasonal variations in the outdoor temperature. Other outdoor considerations include the fact that the heat pump needs to be protected from the wind. It's preferably on a south-facing location. It needs to be on a solid base or surface to reduce noise from vibration, but vibration pads and flexible hoses do help keep noise to a minimum. Noise is an important factor. There is vibration noise created by air source heat pumps. It tends to be less than two people having a conversation, and some air source heat pumps have even achieved the quiet mark in terms of their decibel levels. Further important factors are that you need to ensure there's clearance around the pump, so there needs to be good airflow, and you need to be able to get around the pump to deliver your annual maintenance or carry out your annual maintenance. And condensate, this is important, it needs to be collected in a base tray. What it doesn't need to be done is to allow it to drain out over any path, because what will happen is in winter it'll freeze over and it'll become a hazard. The most important factor in getting an air source heat pump correct is the sizing of the unit. If done correctly, that's great, but incorrect sizing is the thing that creates bad performance. So it's crucial to have a heat loss per room calculation carried out, and this will take into consideration personal preferences. So some people like their bedrooms hot, some people like them cold, but you must not buy a heat pump until you've had a room by room heat loss calculation carried out. This will determine what we talked about earlier in terms of underfloor heating, whether your radiators need upsizing or if their thickness needs adjusting, or in some cases perhaps you can have an aluminium radiator installed, which allows heat to radiate more quickly. There is some potential to use fan convector heating, but by far the best solution is underfloor. Underfloor heating works absolutely best with an air source heat pump. And if you have it installed by someone who is registered with MCS, you can actually claim under the renewable heat incentive, which you can make a quarterly claim, and that is guaranteed for 7 years. So that's worth looking into. Other considerations include possible planning permission, and definitely you have to apply to the district network operator to make sure that the grid can take the added input. I don't think there've been any declines on that application, but there's a potential problem going forward as more people take this technology up. So on an ongoing basis, an annual service is required. Fairly minimal, just a visual check to check that the condition of the shell is okay, it's not broken or cracked, someone's not kicked a football against it, and to make sure there's no debris, so the fins and the outlets are not obstructed in any way, shape or form. Check that the condensate drain outlet is clear and that no hoses are broken and that there's enough glycol in the system, and that the remote control settings are still fit for purpose. A unit tends to last about 15 years, and the only issues come from the design stage, as we've touched on before, in terms of over or undersizing the solution. And finally, to price. A gas or oil boiler under current circumstances will cost around £5,000. A fully functional air source heat pump, if we need to do glazing, if we need insulation and an adjustment in radiators, you could be looking at £12,000 to £16,000. So not a cheap option, but it would seem that it is somewhat inevitable in terms of reaching carbon net zero in the built environment. So thank you for listening. Please visit my website, www.so-ren.co.uk. Drop me an email or fill in the form if you want any more information, or a no obligations free call to chat over this issue. Thanks.